Oh.
Hello, Steve. How are you?
That's a real person. Where I'm finished. Sorry, so where you said you still will go. Where's that? Alright, you're done? Why are you going back in again? No, why? You sure? Right, so the two types of lenses are convex lens, concave lens. Look at the rays. When the rays enter, they merge to one point called the focal point. That's the convex lens, right? Concave lens, on the other hand, the rays move away, they diverge. But if you draw the rays backwards, you will see a virtual focal point here. All right, so make a note of that quickly. Okay. Right, you're done? Right, under that now, let's take a look at, let's try to draw this ray diagram. Actually, no. While you're waiting, let's do some labeling on that convex lens. Let's label a couple of pieces on it, couple of parts on the convex lens. On my mind.
Oh yeah, nah, that's I feel like it's the unloved something.
You all done? All right, so I want to put some labels there, right? Actually, I'll label it here too. Let's see how this thing works.
What is going on? Right, why is it evening now? Wake up, break my head up.
All right, I'll fix that after. I'm forgetting tools, right? We can work in on this after. Right. So, right, we only focusing on the convex lens, right? Right, we only focus on convex lens. So let's say I drew the lens like this with a straight line. Right, Justin? There are a couple things that we need to know on this line. Number one, the middle of that lens, we call that O. O is the optical center. All right, perpendicular to the optical center is an imaginary line called the principal axis. Hilaro, not principal. Everything feeling wrong. Ali, everything is feeling wrong. I'll check back this now. All right, so this imaginary line here to the optical center, we call it the principal axis. All right. The point where all the rays were going through, we call that point F. That is your focal point. From O to F, we call that the focal. We call that the focal length. Right? We call that the focal length. Sometimes. Oh wait, you're not seeing up there. That's optical center, right? I didn't realize that's missing as well. Oh wait, that's zoomed in there and go again. Zoomed in there too. Right? O to F focal length. Sometimes we use the letter lowercase f. Okay. If our object was here, if our object was here, we call this distance the object distance. And the letter we use is, what was the letter? U, right? Letter is U. We call that the object distance. Basically, how far away the object is from the optical center. And let's say the image is here. This distance here is B. We call that the image distance. All right. So it's just a couple of things that work to learn. And there's one imaginary plane. There we go. And there's one imaginary plane called the feeling hot. I get sitting on that. Feeling hot. Once I'm more than 3 required. More than 3, like, you know. Right, right. One more thing that's missing here is something called, that's this imaginary line here. That line, we call that your focal plane. All right. So principal axis, optical center, focal point, focal length, object distance, image distance. All right. So now what we're going to learn now is we are going to learn, if I place an object here, Diana, where is the image? And what we can learn about the image. Okay. So we are going to learn to place an object here. And then when the rays of the object goes through the lens, it's going to produce an image. Right? We are going to learn about the image. Okay? Copy down that.
Right. Right. Friends, but.
All right. So that's just some definitions. So when we go to read diagrams, you'll know what all these things are here, right? So here's what we are going to do. We are going to place an object here. And then when the rays pass through the lens, we are going to try to learn about the image, right? And there are a few things that we're going to see. If the object is here, you're going to see that the image will actually look like this. So the image is going to be upside down. Sometimes you will see the image twice as big. Sometimes you will see it much smaller. Sometimes you will see it the same size. Also, you will see the image being formed at different points. That's okay? And then we'll observe if the image formed is actually virtual or real. That's all right? So the only way we could do that for now, until I show you lens maker formula, we are going to look at something called ray diagrams, but these are scale diagrams. So you're going to have to use a ruler. And my advice here, you'll see these lines here. These lines are not 1 centimeter. So you'll have to measure it. If you have graph paper, yes, use graph paper. If you do have graph paper, go in a book. What up? Nice. Well, the cashier, half of them don't have it. How many people need graph paper? One. What have? Everybody else have? How many need? So by hand, 1, 2, 3, 4, 5. Online, you'll have graph paper. And if you'll come, I'll give you, right? Right, couldn't get. Couldn't get. Anybody else need? Everybody have? Right. Next subheading, using ray diagrams. Using ray diagrams to find the image. Using ray diagrams to find the image. Whichever one you're gonna have the ray diagram. Using ray diagrams to find the image. Right? While we have all of this here, on your graph page, back to your notes, write this formula here. This is called the lens makeup formula. Right? We have a lens makeup formula and it looks like this. 1 over f is equal to 1 over u plus 1 over v. So I'm going to show you how we can use this on every single graph. All right. So let's see if you can do this on your graph paper. Right? All you need is one graph page, right? One graph page could take 3 diagrams. One here, one in the middle, one here. Right? Please don't waste the whole graph page, right? One graph paper could hold 3 diagrams. Oh shucks, I need 4. All right. Here we do, right? 1, 2, 3. You can't fit 4. You raise to go 5 on me. Here we'll do 1 in a notebook. Do this first one in a notebook. And do the next 3 here. All right? If you have enough graph paper, go right ahead and use it. All right. So what are the things that we need to learn about the image? Right? Online, if you're not seeing what I write in, let me know. Huh? Right? The dimensions that I could write on have changed on me. Right? So what are the things that we need to learn about the image? Right? So the things that we need to learn about the image are, number 1, we need to know if the image is real or virtual. Right? Real simple. You're looking to see if lines meeting or lines not meeting. That's all. Okay? If lines meet, real. Lines don't meet, virtual. Number 2, we're looking to see the size of the image. The image could stay the same size. The image could be maximized. Or the image could be minimized. Those are the 3 things that the image could undergo. Right? Next, we have to know if it's upright or is it upright or inverted?
So you can study there and there and get it.
Right, inverted or upright. And one more thing we need to know is position. So for those who only have one graph paper, we are going to do the first diagram in a notebook. All right. We are going to do it not here, not here, here. Please don't draw a line too high up on the page. Right? So it's about 3 or 4 blocks down, right? Please don't do this because you're not going to fit much. I go a little high, right? All right, here's what we're doing. Draw your optical center. Sorry, draw your principal axis. Right? That could be about 8 centimeters. Could be longer, 10 centimeters. It don't matter. 10. You can work with 10. Right? And because you're borrowing and begging for graph paper, we'll keep everything small, right? Lens. This is your lens, right? I don't have to draw the curve, I just draw a straight line for the lens. Right? Split it in half, 5 and 5 centimeters. Okay? 5 and 5. So I want you to write OF, O to F, yes. It's 5. You use 5. And you would die if I don't want to do that. I forget that. All right, chippy, all right. Right? 2 centimeters, 2 centimeters. Here's O. Do the same thing here. 2 centimeters, 2 centimeters. Please do not average. You have to use rulers. If you're using your graph paper, 2 blocks, right? On either side. Blocks on either side. Right?
No.
Here's okay. Here can be like 3 blocks, 3 blocks. Here the water meets slow. The lens could be about 6 centimeters. The lens not into enough proportion. Yeah. Done. Well, not good. Maybe I go pretty first. Leave it for we leave but ready? So we're going to do the first one here, right? You don't do it in the graph book, although most people do it in the graph. All right. Right, so here's what we're doing. The objective of this whole exercise is to learn about the image. So I'm going to place the object. We have 4 diagrams to do. We're going to place the object here, 1, but we're doing this one last. We're doing 4, 1 here, 1 here, 1 here. Okay? So you place in 1 here, then here, then here, then 1 here. Placing the object at 4 different points. Right? The one that we started first will be at 2F. So I want to draw arrow at 2F, 2 centimeters high. Please, from the tip here to the bottom, 2 centimeters. From the top of the arrow, right? The entire arrow is 2 centimeters. Draw that. And I'm going to give you the instructions now. Draw the arrowhead. The arrowhead. No, we put in the arrow at 2F, which is 4 centimeters from O, and the arrow going up 2 centimeters. All right. So how do we figure out where the image is? All right. So we have 2 ways to draw. Right. So I just put in a little note here for you to draw the rays. Rays to draw. The first ray, you're drawing a ray from the top through the optical center. Allow the ray to go straight out, right? Draw a ray from the top of the image, top of the object. Top of object. Top of the object through the optical center. Top of the object through the optical center. Top of the arrow through the optical center, and you will get a nice straight line. You have to be exact. Draw the line all the way out to the opposite side. Right, next. Ray 2. Second ray. You join a ray from the top of the object parallel to the principal axis until it reaches lens. Right, top of the object parallel to the principal axis, I call it PA, until it meets the lens. Everybody okay with that? Top here, parallel until it meets the lens. Right? Please try to make sure it's parallel, right? And last part, same way. When you reach here, you start at the lens and you go through the focal points. And then the rays will meet. The green ray and the blue ray. You'll see the meeting? Right? And where the rays meet, right? The rays supposed to meet there, right? So where these two rays meet, you draw down and you draw an image. This is your image. It's supposed to be at 2F here. Pardon me? Wrong. Have to be at 2F. Those on graph paper should get it at 2F. At 2F, yeah. If you do it properly, it should be right there. Online, you all got it at 2F? That is 10. When I block the hole. Yes, police. Okay, you ready? So when I finish, we have to describe it, right? We have 4 things to say about it. We have 4 things to say about it. And then we're going to use lens maker formula on this one time. Because I know what both sides for you. Sorry, I want to do it near.
I don't get it. Say.
Right. Ready? Are you ready? Nice. Let's start. Is it real or virtual? It's real because the 2 rays met. So we can say that the image is real. Second thing, Is it the same size, maximize or minimize? Right? On graph paper, you all will recognize that it's the same size. Right? Next, is it upright or inverted? Look at the object. Look at the object. Look at the image. They are upside down. So we could say that it is inverted. And for position, we could say it's at 2F. Yeah, make sure that you finish this. Right? Those are the 4 things that we need to know about the image. All right? But here's what. We could also calculate this, We could also calculate it. So I come in here. Okay, no, I'll come in. Let's see if we could use the lens maker formula and calculate a few things. All right? Here's how we know. We know that the focal length was 2 centimeters, right? And it's okay to work in centimeters, right? But just remember, if you work in centimeters, the answer will also be in centimeters. All right? So this is 1 and 2. Our image distance was how much? 2 centimeters, 3 centimeters, 4 centimeters. Yeah, that's correct. Was it 4 centimeters away? Plus 1 on V. So let's make 1 on V the subject. Carrying this here, I'll get a half minus 1 on V. A half minus a quarter, sorry, is a quarter. Cross multiply, and you'll get V equal to 4 centimeters. Right? Okay, next time. So V is equal to 4 centimeters. So let's check and see. 1, 2, 3, 4. So the image is 4 centimeters away from the outer. Y'all see that? Kalina? Kalia. Same. Right? So we know, here's how we can tell. Number 1, we could tell that it's real because this value is positive. Right? V is positive. We could tell it's at the 4 centimeter mark, so we could tell here. We could tell that V is 4 centimeters, so we could tell that it's at 2F. Right? Inverted, because it's real, we know that it's inverted. All real images are inverted. Okay? But the problem is, how would we figure out the sides? Any ideas? From this calculation, we could see real, inverted, where it is. How we could figure out the sides? Huh? Easier than that. How we can know the sides? How you know the same size? What you did? You count here is 2 and you count here is 2, right? So if we use something called this, if we use magnification, magnification is V over U. What you'll get? You will get 4 over 4, which is 1. 4 over 4, 1. What does that say? Was it magnified? Was it minimized? Did I say the same size? Yes. Right? Magnification is 1. Everybody okay with that? So every single thing came from these little formulae here. Huh? The focal point is what I gave you.
No, but I like it.
So I use lens maker formula, right? F is 2, U is 4. 1 on 2 equal to 1 on 4 plus 1 on V. Move it across. A half minus a quarter.
Oh, yeah. Oh, yeah. Oh, yeah.
Don't worry, yeah. All right, copy it down. Let's go again. Right? Do our next diagram from it. Same dimensions. But instead, put your object here. Put the object between O and 2F. Exactly in the middle, right? So we have one calculation. Put it at 3 centimeters. Between O and 2F. No, between F and 2F. Put it here now at 3 centimeters. Online, if you're confused, let me know. Huh? So we're going to do the same thing again. But place the object 2 centimeters at. Place the object here.
Oh, yeah, one and two with the first one. Oh, see, one, two, three, four, five, six, seven, eight,
No, you can.
okay, behind this one, take one.
Oh, yeah. You want to raise now? I wouldn't have my picture. Go ahead. When you work it out, you have two things to do. Describe the image and use the formula and make sure you get it correct.
That's one.
Right, so remember the objective is not to just describe, but to also use the formula and make sure you get the same values, right? Right, the formula will tell you if you got the value correct or not, right? Everything is the same, huh? 2 centimeters, 2 centimeters, 2, 2, right? And you're drawing the same two rays.
Well, yes. That's not, schools also, they're also things, that's really interesting. I don't want 7 example. Those very similar. Yeah, like no, yeah, the change five, but like.
Ready? Ready? You all got it? Right, so you're drawing a ray parallel to the principal axis through the focal point, right, through the optical center, right, something like that.
Yes.
I got my image quite down here. Right, what we can say, describe this one, yes, Araya. Describe the image. Huh? First one is real. Maximize is bigger, nice. Inverted or upright? Inverted. Last one. Where is it? All right, good job, Nathan. So it's beyond the 2F. Outside here, right? That's okay? What is that? That's okay?
Yeah.
Okay, change it. Now you got the formula. Use back your formula and see if your V corresponds with what you got. Right? How far was this? How much? How much? How far was this? 5.8? 4.3? Okay, work it out. Work it out. Let's see who got it right. Huh?
My top should go.
You got it?
Yeah.
So you had to work it out now. What's the focal length? Huh? Yeah, but no, you have to calculate and make sure what you got for your V is the same as what the calculator give you. Right? So 1 on 2 and U was 1 on 3. Yeah, this is 3 centimeters away. 1, 2, 3. Oh, you have work it out. I have a half minus a third, which is 1/6. So the correct answer is supposed to be 6 centimeters. Not 4 point something. Check it back. You were in it wrong. What I got 6?
I've no when my child. It's for me. It's all shit. I don't. Looking serious. Yes, serious.
Right. Go again, Nadia. Go again. Place it at 1, 2, 3, 4, 5 centimeters. Is it at around 5 centimeters and then squeeze it at 1 centimeter? Is at 5 centimeters and 1 centimeter.
I can say this. Yeah, not. Hello. Hello. What? No, that's not. As I get up. What they need is. Check, but maybe that's. Maybe that. Very excited to class. No, we didn't. There's four labs we don't speak. Ah, okay. I remember seeing class four is really good. Oh, something else.
Oh yeah. 5 centimeters.
Oh, I see. Yeah.
Anything else? That U is 5 centimeters. Oh yeah.
What?
Right, so next we'll go here 5 centimeters away. Draw your object. Right. Draw your ray through your focal point, through your optical center, and it should meet a little bit earlier, right? And then do it over between here. Abdullah, they might need one. Abdullah, they might need. Sorry, on. Again. Okay, hold on. Yeah, who else need this one here?
I don't think so. I don't. One, two, three, four, five.
Oh, yeah. Last 2 minutes. Right, y'all finish this one? Right, what would be the description? Number one is what? Real. Number two, minimize, inverted, and between F and between F and 2F. All right. Now for the hardest one, right? Whenever your object goes between O and F, you no longer have something that's real. Right? You're gonna get something that's virtual. So when you join this one, do not go too high to top of the page. Come a little bit lower because your image going to be on this side high. Right? So drop your diagram down about 4 or 5 lines before you draw it, right? Which one?
New one.
Yeah, looking okay from here. Right, last one that we're doing is between O and F. Try and let it be at the 1 centimeter mark. And then to do your raise again. Right? Will these rays ever meet? Okay. Rays will never meet. So I'm gonna show you how to get the image, right? Right, everybody look here for 1 minute. Look here for a minute, right? Ready? So watch here. When you draw the object, right, between O and F, what will happen is that these rays not going to meet. So what that means is that they're not going to get a real image. We're going to get virtual image. So how do we obtain the virtual image and where it is? What you do, instead of drawing the rays like this, you draw the rays backwards. And you would recognize that it would meet somewhere. Right? So draw it backwards like this. Not solid, broken. Right? Draw the ray backwards. Where they meet, that's the top of your object. Image. Right? So between O and F, these rays are not going to meet, or to draw them backwards. Right, describe it now. Right, just describe it there. Write down the 4 things that describe it. Last one. All right, online. So this one here is the only one that'll give us something virtual, right? Between O and F. Right? So again, I want to describe it. So once it finish. And then let's just fill in a past paper. No? Two past papers. Right, we still have one more thing to do in waves, so that's electromagnetic. We have to read the EM spectrum and they can describe it. So let's all read up on that. Right, describe this one, please. Megan, describe this, please. In front. Yeah, Megan.
Say upright.
Upright? No. We started read or virtual.
Well,
Next one is
Natalia, I haven't seen how let me show up on the principal's office, please.
who's that? Yeah, virtual size. Upright or inverted?
upright.
Upright, and where is it? Right. When it is describing where it is, here's what you see, right? On the same side as object between F and 2F. All together? No? Can we get that?
Yeah.
That's not what, let's work it out and make sure. Right, let's just work it out and make sure, right? So that's 1 on 2 is equal to 1 on 1. So you'll get 1 on B is a half minus 1, you'll get minus a half. Correct? Okay. That's right. What does the minus sign indicate? Right? Minus sign means it's virtual and it's on the opposite side or the same side as the object. Okay? So this minus sign here for V represents that it's a virtual image and it's on the, sorry, that should be minus 2. Same side as the object. All right? Let's read in a past paper and we are done. Lens is normally a nice topic once you remember these things. But everything is a nice topic once you remember.
That's not the week of. That's 2019. I'm going to start.
All right, let's try this here. Last one. Do I make it draw the wrong way? Can I get this last one? Right, because this here you have to draw that. Don't worry about that, right? Good draw.
That was good.
Do I make it draw this? No,
I agree for the.
Let's start here. Let's start here. What year is this? This is Jan 2016. Jan 2016. There's a code for this too.
Oh, Brian.
Already. Nice to meet you. Thank you.
Alright, ready? Let's start. This wouldn't take long, this question's really short. Work it out quick. Maybe online, you'll give us answers too. Calculate magnification. They give you image height, object height. Right? I know I didn't write this one down. I only wrote the new version, right? But to find the magnification is image height over the object height. Gabi, where you get it? 2.6 and 2.4. How much you got? Huh? 1.5, right? Nice. For the same magnification, find the image distance. Remember, M have two formulas. This one here too. Just make B the subject. And magnification is B on you. And you found magnification. So B is what? Magnification multiplied by U. And so I you got up. Just drop the nails. Right. Just drop the nails. Yeah, right. Who's it? Yes, Jenny? Huh? Yeah? Hey, message, bro? Huh? On the board?
Yo. We sleep, yeah.
Right, so I got 1.5 multiplied by 20. Right, I got 30 centimeters. How are we gonna find focal length? Yes, that's what. How are we gonna get focal length? 1 over f equals to what? 1 over u plus. Nice. Work it out quick. And leave finish. Calculate what is it? Addition. Work it out quickly. See what you get. Please remember to flip your value over here. 1 on 20 plus 1 on 30. How much is that?
We make a very like access drama. Like you like them from people. I don't know anything.
Right, I got B to be 12. 12.
How much time left?
Yeah, 12. All right, last one, are we done? No? Two more then. Huh? Come on, two more? I just I never said I was the last one. Okay, that's part B. Let's do part A now. Right?
What?
That's part B. Let's go on to part A now. This question is extremely short. Last one, and we done.
Same
Same thing again, real easy.
last time I checked before B is not B.
No, the printed wrong. Hurry up, find those things fast and we done already. We done. But I'm not going to see me for 2 weeks. Wait, 3 weeks. 3 weeks.
Wait, actually, say.
Well, yeah, I think I make a mistake on that timetable. But I'll check it. Right, crash course, it says 9 o'clock. That's a mistake. Was it start 8 o'clock? Quick crash course. Anyway, I'll fix it after the first day.
You don't know what you're talking about.
That's my fun lunch. What? That's not funny. Pare di wakana, di mana lu kain?
Hey. Oh, no, you're true. Davi, oh, you're going to be done. Still have more? What's that? Height of the image. When you're done, part 3 is height of image. Thank you, Justin. Again, the answers online. Right, find the height of the image and tell me if it's virtual or real. Oh yeah. I know that's. Right, object height, they gave us that. 18 centimeters is what, Chris? 18 centimeters is what letter? U. And the 12 centimeters, what letter? E. So now 1 on F is equal to 1 on U plus 1 on B. 1 on 12 is 1 on 18. So I got 1 on B as 1 on 12 minus 1 on 18. How much is that again?
1 on
So B as 36.
Yes.
How do we find magnification? Pick one. How do you find magnification? Ariel, magnification is what? Huh? V over. Nice. So that's 36 over. Which is 2. But after image height. Right? So we could use magnification as what? How we get image height, Javi? No, what's the formula you're using? Magnification is what? Image height over object height. And it gave us image height, object height here. And we know magnification.
That's true.
So that'll be what? 7.2 multiplied by 2. Anybody got that? 14.4? Right, last part, virtual or real. That will go to sing. Virtual or real? Huh? Real? Why? What positive? Sure? Right, yeah, correct, real. Last one. You'll do that real fast. I am done on it. Alright, that's it. Right, so as I said, your homework, read up on electromagnetic wave.
Ow.
Right, yeah, I didn't do that.
Wait, EM is a grand school, so I'll read it.
Yeah, read up again.